So good afternoon, good evening, or good morning, everybody. Thank you for joining us in live or for watching this webinar online. So I am Mihai Mitra from Institut Telecom, and I shall introduce you Neural Network Traceability, a new standardization project led by MPAI. Of course, neural networks are today one of the most valuable assets. They are deployed in an increasing variety of domains, from autonomous car driving to financial optimization or to medical decision support, to mention just some examples. This solution or solution based on neural networks are continuously renewed, and this process is followed both by industry and by academia. And they are feeding large variety of both integrated or distributed solutions. Why traceability is useful for neural networks? It's useful because machine learning and deep learning, it's a costly field. Buying AI solution ranges today from 6,000 USD to 3,000 to 300,000, or renting or subscribing to some pre-built module or services might cost even 40,000 USD for a year. And behind these services, there are several types of ways in which the AI solution are wrapped and combined together. Behind any AI can be multiple alternative neural networks that can provide an inference, and identifying with precision the ones that actually produces the inference, it's important. AI solution can also be shared among multiple users, and keeping the track for this process, it's useful for fair monetization and trust in usage. And unfortunately, AI solution can be also altered by malicious users, and just think about an adversarial attack applied to some unmanned vehicle driving. So under such circumstances, identifying malicious modification will avoid faulty functioning. So we reached the conclusion that ensuring traceability and integrity for neural networks becomes mandatory for more and more applications. We consider under the MPAI framework a broader landscape related to the traceability of neural networks. So by traceability, we understand solutions that enable identification of the origin or the verification of the integrity of data. For neural network, traceability enables understanding and tracking the distribution, the storage, the exchange, the use of NN models. We consider two categories of traceability techniques. First, the active techniques or the watermarking techniques that are achieved by modifying the model to be tracked. And secondly, the fingerprinting or the passive technique, which do not modify in any way the model to be tracked. So neural network watermarking was already studied by MPAI, and we already released standards specifically devoted to this application, neural network watermarking. And watermarking provides tools allowing to imperceptibly and persistently insert some data into the original content. The main properties of watermarking, and these are also inherited from the multimedia background of watermarking properties, relates to the imperceptibility, to the robustness, and to the data payload. Why neural network watermarking? It's a particular field. What changed with respect to the multimedia content? It's because the watermark insertion is no longer static as it was for the media, and it became dynamic, as the watermark can also be inserted during the training and be detected from the inference produced by those watermark data. And the second particularity is that the evaluation of a watermark impact in the inference of a neural network becomes far more complex than it was to evaluate the subjective quality for multimedia content. Coming now to fingerprinting, and this is new for new study topic for MPAI. Neural network fingerprinting can be conceptually abstracted as the process of identifying human's identity into a repository. Some 140 years ago, it was brought out that the dermal edges and ridges on the tip of the human fingerprints are able to identify the person identity. They are unique identifiers. And although they are small in their size when compared to a human body, they are able to identify that, assuming they were properly extracted and registered into a database. So what it's now fingerprinting for neural network? We extract some data. These data are expected to be small with respect to the size of the model, and they are expected to be able to identify the model in its as a whole. So we have the fingerprint extractor, and we have then a second operation paired design with the extractions, that it's the detection, that it's supposed to be able to identify the neural network model from whom those informations, that fingerprint, has been extracted. So the fingerprint extractor and detector, it's usually parameterized by some secret information referred to as a key. This is much in line with the watermarking property, with the watermarking background. I apologize for that. And neural network fingerprinting has three main properties: the uniqueness or the unicity, the robustness, and the search efficiency. In a nutshell, uniqueness means that fingerprints extract from different models are different according to some similarity measure or according to the fingerprinting detector output. Secondly, the robustness means that the same fingerprint is extracted from the model and from all its near duplicated versions. By near duplicated version, we understand here the modification of the neural network models, such as fine-tuning or pruning or quantizing tiller levels that do not impact from the application point of view the inference. The search efficiency, the third property of the fingerprint, relates to the possibility of achieving this fingerprinting process with a given pre-established and control computational complexity or computation duration. MPAI identified several use cases for neural network traceability. Some of them are common to watermarking and fingerprinting, where other can be specific to one of these two technologies. For instance, we have the possibility to identify a neural network, and the identification data conveys information about the neural network itself. To make it maybe clear, this identification data can be the payload inserted in the model according to a watermarking approach, or the fingerprint extracted from the model according to a fingerprinting approach. Second use case, it's there where the neural network traceability data are served for verifying the integrity of a neural network. And a third one relates to the identification of the actors in the neural network distribution, storage, modification, or usage. Specific for watermarking, we may have multiple watermarking use cases in which several payloads are successively inserted in the content to identify how multiple users may change the network. To answer these use cases, the MPAI NNT standard, so MPAI neural network traceability, has a scope to specify methodologies that are able to evaluate the following aspects of neural network traceability technology. First, how well an NNT detector, decoder, or matcher can detect, decode, and match traceability data when the tracked neural network has been modified. So this property much relates to the robustness. Secondly, the computational cost of injecting, extracting, detecting, or matching a neural network. And specifically for active methods for watermarking, the impact of on the performance of the model, the impact induced by the data payload that have been inserted in the model. We have here a global view on how this technology behave. First of all, we can evaluate for the watermarking method the impact of the data payload in the in the performances. What it's illustrated here, it's how some data injected in the model can modify the model functioning, specifically the inference produced by that model. The second aspect relates to how the detector or the decoder are able to identify and to retrieve and to identify the model. Related to the fingerprinting provider, the extractor and the matcher are assessed according to their robustness properties and also according to the processing cost of the process. Some general view about our timeline. The NNWDC established for MPAI started its work some 2 years ago in 2022 with interest collection that was announced during the MPAI General Assembly number 16. 1 year later, in January 2023, we issued our first standard. The reference software follow very quickly in April 2023. And 1 year ago, in November 2023, this MPAI standard have been adopted also by IEEE under the number 3304. So while all this work was related to watermarking. During 2024, we start our efforts for extending the scope and covering also fingerprinting application. And not even 1 month ago, during the latest MPAI General Assembly, the number 50, we issued the technical specification for neural network traceability. We target our reference software to be published and to be available during the spring of 2025. If you are interested more on the software side, so today we have ready the software resources for the watermarking part. It's a collection of 4 type of resources. The first one represents a flavor of the standard instantiated for a classification task and for 2 watermarking methods. This software can be used as a ground for instantiation for other type of watermarking method and task. The case 2, it's a straightforward extension of case 1 that can be seamlessly used and integrated with MPAI AAF, so AI framework. And this implementation is also in Python as the first use case. Case 3 relates to an implementation, complex implementation related to multimodal query with watermarking. So we demonstrate here how neural network watermarking can be integrated with generative AI. And finally, the 4th case explore maybe the other applicative limits that are the under-parameterized models, and we show how NN based image classification method can be watermark when deployed on low power and low resources devices, as the one, for instance, required in Internet of Media Things. This QR code and the link you have down these slides allows you to directly reach our software resources. So, what are our next step to keep the track on to bridge this gap in software reference software development? We are not far away, as I told you. We are some months behind, and these months are to be cleverly used for fixing and cross-checking the software grounds we have already available and that are already changed during our weekly meetings. We shall go on also to create an open reference software IEEE repository for our project. And as the future always starts today, we shall keep on exploring complementary security use cases, other way speaking, to go beyond watermarking and fingerprinting. Uh, I thank you for your attention, and you have here several links if you are watching this webinar offline as a video resource. Don't hesitate to contact MPAI and to contact us. We'll be happy to interact with you. Thank you.